Okay, so on this paddle board here, I ran the test program and it showed that pin 19 does not work. So the data goes in, I send a 0 volts out, and I get 3.3 volts in on the pin here. I read send 0 volts out here on one of the IO Warrior IO bits, goes into the transistor, and I get 3.3 out here. So the question is now, what voltage do I get here in the middle? And then it will tell me, oh, maybe this transistor is messed up, or this one is messed up, or whatever. So I take the voltmeter. Now the test program, I have it a breakpoint, so it got the bad voltage and then stopped, so it still holds the voltages that were bad on the pins. So I should just be able to measure voltages with this, and it should work. Should show me. I turn on the voltmeter, and I should check again here. Let's see, 1, 3, 5, 7, 9, 11. Yeah, 3.3, and then a couple millivolts going in. So I have a couple millivolts going in the base here, and that should be high at this point, high voltage, 5 volts basically, and which should give a low voltage here. So the thing to do now is to see what is the voltage here. And that is buried down in here somewhere, but D30, you look at the schematic, I just redrew the part that has to do with this. Otherwise, if I had the whole schematic on there, it would not be all that readable. And here's D30 on the cathode, and it's showing 138 millivolts. Yeah, you can see that on the screen here. 138 millivolts, so that's no good. That shows 100, I'll just put 0.014 volts. That's no good. Okay, so that means this has is basically almost shorted to ground, so it could be any one of these. This transistor or this diode or this transistor is shorted to ground, and no real way to tell, because again, 0 volts going in here, this transistor should be open, and then this pull-up resistor should pull it up to 5 volts. So I guess it's possible that this resistor doesn't work, but that's not very likely. So I guess the thing to do is to pull these transistors out. So we can pull like Q62 out and see what happens to the voltage. So I'll unplug this thing and change my glasses. And find Q62 on there. That one. That's the 5-cent transistor, so we'll pull that one out first. The other ones are 10 cents, right? The MOSFETs or something like that. Q62, don't want to pull the wrong transistor out. That one right there. Let's see how I do with this. Yeah. Oh, chances are I fried the MOSFET though, putting the MOSFET in. Maybe I should pull that out first. Yeah, do that one. I changed my mind at the last second here. That's most likely what's wrong, right? The MOSFET is shorted. So, I'm trying to get that out of here without making too much of a mess of the circuit board. Double check that Q46, yeah. Before I unsolder too much of it. Mm, 2, 3. I'll take this out. If I get this out of here, I can see if it opens the circuit up. Right? If it still stays shorted, then it's something else. Well, of stuff in parallel at that point. One. Where's that thing? There it is. I just kind of pry them out one at a time here. I hope I just stick with this transistor and not start doing them one by mistake. Yeah. Oh, jeez. Oh, pull. Oh, God. Coming out little by little. These circuit boards are pretty good. They stand up quite a bit of abuse. Oh. Might have to be cut out to get it out of there. I got one wire completely out. I gotta get the gate. Does not seem to want to cooperate. It needs more persuasion. Come on out of there. Pull, I say. Come on, you can do it. I'll try this drain again. Alright, well, I'll just cut it out. And then I'll clean the holes out later. Come on out of there. Poor little nitwit thing. Right. Now, let's see if I plug my voltages in. What do I get? Plug the power in here. Now, it could be the NPN transistor is grounding it out, so I gotta check that voltage, but let's see what we get. We'll put the voltmeter on here. And then check the diode. No, what's it got? No, that's 400 millivolts. Well, that's a lot more than we had before. What's on the base? Yeah, see the transistor is being driven by this chip, so I'll have to start the test program over again. Get me into the Alright, so it's back on the bad step again. I don't have a setup to show the test program here in the video. Let's see what the base is now. Hopefully the base, yep, okay, the base is down to a low voltage. And this is still only 140 millivolts, so we sacrificed the poor MOSFET for no reason, it looks like. Alright, and double check. Base is 5 millivolts. The collector is only 138 millivolts, so that transistor is shorted, or that diode is shorted, or we're not getting 5 volts into it. I guess the next thing to do is, before I needlessly pull out another transistor, is I could check to see maybe the pull-up resistor isn't working. So I could use an external pull-up resistor. Okay, maybe the thing to do now is try, maybe it's a pull-up. We'll just guess, because that's something you can test without tearing anything off the board. So we'll try that next. I gotta grab a 120k resistor here. The pull-ups are 100, that's 120, close enough. And let's see, get some clips. Well, I'm doing a couple of these jumper readers here. That should be enough. 5 volts on one end. Ah, shut up. Beep, beep. Now, let's see. We'll get this clipped on 5 volts somewhere. I think this capacitor here. Let's what side is 5 volts now. That's the 0 side. That's the 5 volts. Okay, so I can get 5 volts right here. Clip that on there. Now, I'm going to put this on my diode where I was getting 130 and I'm still getting 130 millivolts. Pop. Hold that with one hand. 130 millivolts. Stick a resistor on there. And it goes up a it shuts off or something, this meter. Alright, well, let's see. Got my 130 millivolts. I put this resistor, it goes up to 200 millivolts, but it still should be like close to 5 volts. Check that, yep, 5 volts on that wire. Oh yeah, you can see this, 5 volts. So, if I take this wire with 5 volts on it, and I touch it to that point, yeah, it goes down to 240. So this point here, there's still a short. Even without this transistor, there's still a short somewhere in here. So, well, next thing to try is the NPN transistor. I get rid of this, take the power off, and, oh, you can't see that. Okay, so I took the power out here, the USB cable, and here's the NPN transistor. So I'll try taking that out next. That's the NPN transistor there. And we'll see if that's what's shorting this thing to ground. Alright. Poor thing. Get this transistor out here. Empty wet thing. This is not doing too good. Usually this thing works pretty well. I don't know why I'm not getting good results with it. Oh, come on. Did the soldering iron time out? Sometimes the soldering iron likes to shut itself off. Nope, that's the one it says. Get my other. Yeah, let's see what we got here. Where am I? Right here. This transistor. Come on. Why? Sometimes you gotta put more on to take off. Yeah. Now we get this thing up. I'm not getting anywhere with this. Alright. Here's that transistor. Poor thing. Put this collector out first. There it goes. I just pry it with my finger here on the back side of the board. Whilst I heat it up on the top. And now work on the emitter. Alright, there's the emitter. See if I can get this base out now. not such fun to take stuff apart. And you have to put it back together, of course. I'm just going to use these cutters to pull it out. There we go. Alright, same situation now. We'll plug the power back in. And see if that node can be pulled up to, or should be pulled up with this pull-up resistor here. Now there's no transistor in here, so it doesn't matter what voltage is coming out of the IO Warrior chip here, because there's no transistor, so we should be able to measure that voltage directly and see if it's still shorted. So ground this out, and our pin 1 is ground. And let's see what we got here on the top of the zener. We have 5 volts. So most likely it was that NPN transistor. So I took a wrong guess. I guessed that the MOSFET was bad. Weird. Actually had a bad transistor, it looks like. Well, it happens. Alright. So now we just got to clean these holes out and put new transistors in. I could just stick a new transistor in that. I'll grab my bag of transistors. These are actually left over from the Hode computer. This bag. You buy them by the thousands. It costs about $50 for 1,000 transistors. Ooh, get this in here. See if these 3 wires will just go in there. Those holes are cleaned out pretty good. Yeah, that's going in. Ooh. Oh, the little MOSFET behind it suffered a little. That's alright. Don't want to bend it back and break it. Alright, I got that one. Solder it in. And then check the voltages on it. Ooh. A 1. A 2. A 3. Alright. But you can see the circuits, again, are pretty simple because it's just the same stupid little circuit over and over and over again. Now, you should be able to run the test program. It should still halt there because we don't have the MOSFET in. But it should have the high voltage here, which we did not have before. And I am going to put the voltmeter back here. It should be low now, I bet, because this thing powers up and it usually puts high voltages out. So let's measure this base voltage first. Yeah, we have 0.6 volts. So this should be low. And it is. That's 30 millivolts, 33 millivolts. So this transistor here has 0.6 here on the base coming off the IO Warrior output. And so it's got 30 some millivolts here, which it should because the transistor is conducting. So now if I run the test program, it should quit and leave that base low. Hopefully it'll quit in the same spot. Go over here, run it, yes, and it dies on that bit again. Good. So it should measure a low voltage here on the base. What do we got? Yeah, 4 millivolts. And now hopefully a high voltage here. Yeah, we got the 5 volts. So now when we put 4 millivolts here coming out of the IO Warrior chip, we get 5 volts here. Before we got you know what, 130 millivolts. So it was this transistor here that was shorted out. So now, of course, I yanked this one thinking, oh, I munged the MOSFET. It was the most likely culprit, but no, it was the bipolar. Weird. All right. Anyway, so I'm going to clean these holes up. Hopefully, they will clean up cleanly. And stick a replacement transistor in there. And that one cleaned up really nice. So I got my soldering iron out of the way first. And I kept this thing on the spot. You gotta get both going at the same time. Heat it up. Get the soldering iron out right away. And then let's see what we got here. Yeah, those other holes are being very stubborn. Ooh. Well, let's see. I got the big guns for this. It's not going to cooperate with that. Let's see. Alright, so I got this other desolderer here. Let's see what we got here. This is basically a heated... Yeah, it's warming up. This is basically a heated solder sucker. Come on. This usually works. The other one does not. I think there are wires stuck in those holes. Come on, come on. I'm just going to take another minute to heat up here. Ooh. I sacrificed that MOSFET for nothing. Oh well. Ooh. That's cleaned up pretty good. That came out good. Yeah, it's just being stubborn, the holes. Okay. Well, let's see, are we hot yet? We're getting there. Yeah, there we go. This. And you gotta keep this tip tinned, they say, or it doesn't solder very well. And you have to get the solder melted on the board before you can, before this will pull it out. So you gotta keep this thing well tinned, or leaded, or whatever you want to call it. I don't know why they say tinned when it's mostly lead. Alright, anyway, come on, get off of there for crap's sake. Alright, so we got that in there. Now let's see if this cleans it out. Hold it right on there. Big blob of solder. Where all the buttons way back here. Alright, well, let's see. I've used this thing before a few times. Oh, I can't get my thumb pressure on it. Did I clean it out? Not very well. Oh, this is going to be very stubborn. It probably didn't heat up the actual circuit board. No, actually, hold it there for a few seconds. Oh yeah, that one cleaned out really good. Just gotta get that gate wire to come out. Maybe it needs some more solder on it. Solder it up a bit here, and then see if it'll clean up. Blob on there. Now we'll see if it'll clean out. Oh, without me melting everything else out. Alright, we'll try this gate wire again. Get it on there, let it heat for a second. Oh yeah, that cleaned up. Good. Alright, so we're ready to go. Alright, put this away without melting anything. Alright, there we go. Yeah, I know I can't show you these holes cleaned out, but they're cleaned out. There's a little piece of something in there. Yeah. Even if there is a little bit of that wire, I think there is. The old gate wires, there's a little bit of it in there. I'll see if I can get it out in there. A little bit caught in there. I probably should have just left it where it was. Let's see. Yeah, I can still stick the other gate in there. I think. I'll give it a try. I don't want to ruin these traces, of course. Yeah, that's big enough to put a wire in there. Okay, the MOSFETs. There's a bag of MOSFETs. I'm trying not to static zap it after all this work. Get one of these transistors out. Move everything on the shielded bags together. Oh, get one transistor, not five. Okay. Now the moment of truth. Can I get this transistor in here? Get it right, going in the right way. And of course that gate is being very stubborn. Oh, jeez. What am I going to do? Get that wire in there. Just wiggle it in a little bit. Let's see. Get this grounded out here first. Alright. Well, I'm going to have to try to clean this hole out again, or I'll never get that transistor in there. Alright, well, goop this one up again. Get one more try. Alright, there it is, filled up again. This works good if you get all the solder hot. It usually works pretty good. Alright, well, let's see. Give it one more try here. If I can hold it on there steady. Alright. Oh, it didn't make it then. I must not have heated it up. Maybe it's not tinned anymore. Tin this up. Really good. Get it really tinned up so it'll conduct good. Get my thumb on the button. Up against the board. Ooh, good. It cleaned it out. Yeah. Good. Alright, now. Unfortunately, this transistor I'm not going to trust. The last thing I want to do is put a bad transistor in there. There we go. Got another one. I had another one. Alright, well, let's see. I'll keep my foil bags. Let's see if this wire goes in. It should. Oh, that gate hole is still being stubborn. I don't know. Well, I certainly don't want to put together a new board just because there's one hole. Why is it? It looked cleared out, but I guess it isn't. Oh, yeah, I shouldn't have. I don't know what to do. Yeah, it's not quite cleared out, but it is pretty well. This is not enough. Well, worst comes to worst, I can put the transistor in and solder the gate separately. Alright, well, I'll try that. I have to solder it in separately from the top. Alright, I'll get that soldered in the bottom. Ground this out first, don't forget. Alright, got one in there. Alright, now I'll get a little, push this wire up against the pad. Nicely. Let's see, the gate, where else does the gate go? The gate also goes to the zener. So it just goes like that. Can solder it there to the zener. Just ground it out again. Ground it. Kind of haxery, but that's it. Let's see. Is it really soldered? Yes. Alright. Now the question is, does it work? Got that on there. Alright. Well, let's see if it's fixed. Poor thing. Alright, grab the wire. Let's see, we'll plug the USB in here. Alright, get that going. See what the test program says here. Run. Yes. Alright, the test program is running. So it was this, can you believe it? It was this NPN transistor here was shorted. And that MOSFET is good. This one I'm not going to trust again. So I'll get rid of this. These are all good, I think. Still. And the test program is still running. So it's grinding away, putting random numbers. See, it sends a random number out here, right? And then reads it. This goes back to the a different pin on the IO Warrior. So it just puts a voltage here, a 0 or a 1, and this inverts it once, and then it gets inverted again, so it should read, the 0 or the 1 here. And so it just pumps out random numbers on all 31 pins and reads them back and makes sure they're good, and goes on, does another random number, yeah, and it's still running over there on that computer over there. So this board's fixed. That was a disaster, wasn't it? Poor transistor. That's weird. Maybe I've had one or two bad transistors in the thousands I've put in. So, well, all right, there you go. So that is how much fun it is to fix one of these little boards. And, well, there you go.